Hi and welcome everyone to this episode of Breakpoint. The topic for today is taking charge of your APIs with proactive API security. For this, the guest for today is Buchi Reddy B. He's the founder and CEO of Levo.ai.
APIs are growing in like mushrooms in here.
Where do security teams even start with the process of API security?
Just think about it. I'm not trying to scare the security practitioners here, but just think about the magnitude of the problem.
But do you think this then is the right kind of a use case when we want to use, if we need to use MLs in that case?
Actually, IRCTC is a great example.
Welcome to Breakpoint Security Podcast, folks. Join us as we explore the fascinating world of smart security teams and their cutting edge security and engineering practices. We'll share fun and engaging stories about clever optimization techniques that scale your defenses and also keep your data safe. Tune in and be a part of the conversation where exciting innovation meets real world application in cybersecurity. Hi and welcome everyone to this episode of Breakpoint. The topic for today is taking charge of your APIs with proactive API security. We've been surrounded by microservices and APIs for quite some time now, but when it comes to security, we tend to treat them like the traditional web applications. Let's now explore in this particular episode how do we actually tackle this early on in the product development lifecycle and stay ahead. For this, the guest for today is Buchi Reddy B. He's the founder and CEO of Levo.ai. Welcome to Breakpoint, Buchi.
Thank you very much, Neelu. Thanks for this opportunity. I'm super glad to be here.
So, Buchi, I think this is a very apt topic coming after a very long time. I remember my days when we used to do API security testing. And we used to think, because there were a lot of test cases that we used to run manually. And we used to use traditional web proxy products and tools to do that. And we were thinking for the longest time, when will we actually have a product to automate all of this? So when you talk about API security and you look at the bigger picture, whether you are in a security team on the offensive or defensive side, you will see that apart from the usual vulnerabilities that we get from time to time, you will also have many issues where, for example, you're discovering an API that was not being used, has been deprecated, or older versions of the APIs which are vulnerable, whereas the newer versions of APIs are not, right? So just like we say, shadow IT. There are many cases where in the larger organizations, you have so many APIs being created that it's difficult to keep a track of them. The environments are quite dynamic in these cases as well, and everything is changing for them in infra and application software and other places. With a large environment like that and everything changing so dynamically, where do security teams even start with the process of API security? Like, and how can you actually automate that?
Yeah, I think in your question, you have very well described the challenges. I think you have touched upon changing applications, changing dynamic applications, and most of the applications today are like single page applications or your mobile applications hitting the APIs. So we've gone from server side rendered HTML pages to the modern applications which are completely composed of APIs. And like you pointed, there is changing clouds. It's like let me actually give I was having a conversation with a security practitioner, and this is exactly how he was describing AI, and I felt like he did better than me in some cases. He's like, I have these dozens of AWS accounts, and any machine could come up in any one of these accounts at any point of time, and on those machines, any application could come up at any point of time.
Yeah.
And adding to that, these machines could expose public IP, and I don't know what kind of security configurations are applied and what ports are open, and I don't even know which frameworks these applications are built with. Is there authentication on these APIs? What kind of data they are dealing with? Just think about it. I'm not trying to scare the security practitioners here, but just think about the magnitude of the problem. It's like, it's almost like, again, I'll quote one other dialogue that we heard. This is my favorite. APIs are growing in like mushrooms in here. So this is
Yes.
exactly what one of the practitioners said. So imagine yourself, these APIs are coming up like mushrooms, and how do you protect the data? Where do you start? So when these are growing like mushrooms, you need a solution that can detect mushrooms. It cannot be done manually, and it has to be at the pace that these are coming up, right? And that's where usually, this is a very well-known thing in security. You can't protect what you can't see. So lot of solutions, whether it is cloud security
Exactly.
or API security, is not an exception. You start with the discovery, and a discovery solution that can really stay on top of this dynamic changing landscape and detect every API, like all the ones that you called out, whether it is shadow APIs, whether it is APIs that are very rarely used, not very actively used, or APIs that are used only in one environment. Like, there are cases where an API is never tested in any pre-production environments. It's only active directly in production environment. So, uh, in short, you need to find all these APIs first. So you need a discovery solution that can actually work in the same challenging environment that you pointed. A solution that can work in clouds, different clouds or data center, can detect any application and framework, and like can work with any dynamically changing applications, so that you stay on top of it. And typically what we have seen the best is if security people can get all of this into a dashboard or a portal kind of thing. Like, typically API portals are common on the API gateway side, but that's only applicable for the APIs that you have put explicitly through that gateway. So what I would say is, imagine you get a portal for every API out there covering all the scenarios that you highlighted. That's the great start to actually start solving API security problem.
Yeah, so basically, to simplify this, I would say have the visibility of all the APIs which are actually spinning up. You could use various means to do that, but have an automated system to be able to have that inventory of APIs of sorts where you can see it, you can see what's new coming up, what is being deprecated, and where things are going without manual intervention, because that may never eventually lead to all detecting all the APIs that you have in your environment.
Yeah. Manual is just not scalable because of all
Correct.
the challenges that you highlighted. That's why you would need to completely automate it.
So, while we're talking about automation, there was this aspect that I was talking to you about, and this is closer to my heart because I have worked in API security testing for a long time. This is on the offensive side of security, right? The API security testing. And I think that's the first elephant in the room that I want to address. In terms of automating API security testing, how do we actually, to the first question, how do we actually standardize and automate the testing for our set of APIs? But while we do that, I will also like you to go maybe one level deeper and tell us about the authentication challenges, because one of the first things that I saw when we were doing this, and we would do that for every project, right, separately, because we were on the consulting side. But for an organization that's trying to set up a security testing framework for themselves in APIs, there can be, for any mid-sized to large-size organization, they'll have multiple authentication mechanisms for these APIs that will be spread across, and it may not be uniform, it may not be single. So how do they take care of or handle or tackle this or automate authentication for these APIs? Because that's a fundamental part. So you have to authenticate to the API when you're testing, and if you want to automate that process, it can become a challenge if there are multiple authentication schemes spread across. So how do you standardize it, automate, and then how do you take care of the authentication?
Yeah, on an average, I think based on what I have seen, actually, let me start with the maximum number of unique authentication schemes that are used in a company that I have seen is 20 actually. There
Oh
were
my
like
god.
literally in a
20.
single company, there are like 20 different authentications. When I say 20 unique, Basically,
Okay.
there were like even combinations. So there were cases, header is named as X dash API key. In some cases, it was just API key is the header.
Were they
Um,
selling authentication by any chance?
no, the if you actually go back, the reason it happens is in today's world, like let's go back to the fundamentals, right? We want every business to innovate, move fast,
Hmm.
innovate, and the business needs to move fast so that they grow as a business. And in that process, all the the digital teams or development teams, whatever you call it, they are given autonomy. I think that has become the new culture, right? For the right reasons. So they can pick some of these frameworks, they can use some of the cloud services, and they can start moving fast. And it's a byproduct of that, because everybody is trying to do the right thing by moving fast and innovating. But in that process, if the same standard is not used across the different services, across different teams or different BUs, it is bound to happen.
Yeah.
They're not using the exact same code to actually authenticate service A and service B, basically. So that's how we end up with this situation. And to answer to your question, how do you automate it? First, you should know that there are actually 20. And it again goes
Yeah.
back to the discovery. The discovery, so let's first define discovery, right? I have seen different definitions. Some people just list the paths and they call that as a API discovery. Yeah, you can
Okay.
say that, but you will not be in a position to answer or automate the things like authentication automation that you pointed. So, in my opinion, whatever solution you are building to actually discover these APIs or the portal that you are building, it cannot just be at the superficial level just by looking at the paths. You have to go much deeper, inspect all the authentication details, and like make a note of all these unique authentication schemes that you are seeing across the board. And then that discovery or the portal feeds into this automation. So on the even though it might sound daunting, there are only finite number of authentication schemes. Like you put it in a header, the authentication tokens, you put it in the header, or in some cases they might even put it in the query. But even in the header, it might be a plain API key, or it might be a JWT token. You might use OAuth. The number of approaches are only finite, and you can just automate it very easily. So the real challenge is not how do you codify these finite authentication mechanisms. The real challenge is actually finding how many different authentication mechanisms that we have, and that again can be solved with the automation of the discovery, and your discovery solving this. So that would go a long way. So when you are finding, note down all the unique authentication mechanisms you have and take one by one, and there will be like even half a dozen in an average enterprise, and you can just write the code. There are a lot of Python authenticators to automate it very easily.
Will it also involve integrations with these systems or with IDPs within the organization?
Yes, it does involve. Great question. Because again, going one more level deeper in the authentication, right? When you're authenticating, the cases like long-lived API keys, which obviously is not a very good practice for security, but there are some companies and some some cases they might be using. Those are relatively easy because in the automated security testing, you can just put it once and it will just work across each run. But rather a better security practice is to generate short-lived tokens with much lesser TTL on the fly. And in those cases, you need to talk to the authentication system or IDP back. So you usually provide it with the username, password, and if MFA is enabled, that's where it actually gets to the next level, the whole implementation. You might have to you give a MFA token, or you might have to even programmatically uh, click captchas. So I'll tell there's a Python framework called Playwright. So that you can actually open a browser and automatically do things that you can only do in the browser, because these days it is very common. The most complex that I see usually is one is introducing captchas. And if there is no captcha, because the original token retrieval originally happens through this web application or mobile application, in both of the cases, you validate the captcha. So that's why I've seen cases where API authentication, you cannot even get the token without actually having a mobile or web app. Uh, for the right reasons, I think. So in those cases, the frameworks like Playwright will be helpful. And there are even other cases where you can programmatically verify the TOTP kind of thing. So go through all those cases. But again, those are all codified, and a lot of times you actually find online programs to deal with this. In my opinion, in the enterprises, the bigger challenge was actually identifying that we have all these mechanisms.
Yeah, I think practical scenarios, the things that sound very simple are actually the most difficult to do. That's what my experience is. Just I think, but we are still trying to go one level deeper to understand. If you have solved this, and I'm sure it will take some time to figure that out also, and understand what all mechanisms are there, map it to the APIs that you have, and do the right kind of integrations wherever necessary. But the kind of tokens that you were talking about, does it apply to the JWT tokens as well? Like, or is it different when you want to add those to your authentication?
It is for JWT tokens as well. Like actually, the most common that I have seen is actually using the JWT token because it has become a
Hmm.
fairly common practice. And JWT token with short-lived tokens, like half an hour, 1 hour is generally the
Hmm.
common thing that we have seen. In staging pre-prod environments, they set it to half a day or 1 day because it's not production. In all these cases, the authentication automation, the way it involves is you take the user credentials usually, and if MFA is not enabled, you just basically hit a authentication endpoint and you pass these credentials, you exchange it for a token, and in some cases you have a refresh token, and the refresh token can
Yeah.
be used to continuously refresh and get the new access tokens. And the automation of the security testing needs to be aware of this, and it needs to be smart enough to detect when the authentication has expired, the token has expired, based on the response codes that you get in the API calls. And based on that, you again go repeat the same process and get the token on the fly and pass it in the subsequent calls.
Cool. I think, yeah, this sort of sounds like most important problems solved for APIs. But I was thinking about my own days of testing, right? And there are variety of issues that we try to find. I want to touch upon some of the qualitative aspects of the testing also a little bit here, because you have worked deeply in that area as well. So in terms of customization, so now you will see, while there are different kind of issues that we find by API security testing, we also find a bunch of issues which are related to business logic. And either there are business logic issues, or there are some kind of IDORs, where you are able to access a lot of data for other users or other entities which you're not supposed to do. And there are many such which generally were never automated, and to an extent any traditional pen tester would think it would not be automated, because every endpoint is different, right? It's expecting different things. It has a business context. I think that's the biggest aspect which a human can understand mostly. So how about automating those? Like, have you taken a stab at it? Do you think there is a method to this? Or there can be a formula to this? Can we standardize it to any extent, especially the business logic, the context-based issues?
Yeah, I think we can totally automate a lot of these things. The definition of what is business logic itself, I think, could be first we need to agree on the definition because it might mean
Hmm.
different things for different people. And also the line between the business logic testing and API functional testing, that is also very thin if you think about it.
Yeah,
So it's
I
like
guess.
we even talk to QE quality engineering teams, and in some cases they would even say like, this is all authentication authorization testing, and we test it. Like, why do you even call it security testing,
Hmm.
right? So all these, how do you define? In my opinion, is just on how we ended up here, and also the cultures and practices that different enterprises follow. Because in some companies, even functional testing, in some companies there is QA teams, but in some cases there is no QA team. The developers
Hmm.
themselves are finishing the full functional
Doing the,
testing.
yeah, yeah.
It- It's all about, but going back, what is business logic testing? I take this very simple example, like, let's say, your API is doing simple 1 plus 2 equals to 3 computation, right? 1 plus 2 has to be 3. That, typically you see that that's a functional testing, and usually it is covered in the functional testing. If I pass 1 and 2, I should get 3, but if I pass 4 and 5, I should get 9, right? But taking to the next level, if you take a bank example, that let's take a slightly complex example where In banking, there is a transaction that, for example, you as a regular user, you should be able to initiate this transaction in an enterprise context, but only as an approver or admin, I should be able to approve this bank transaction.
Okay.
And that is when things get complex. And what I've seen, especially when wearing the security practitioner context, what they want to test is only the person with the approver permission should be able to approve this bank transaction. If there is an API call that
Yeah.
I'm making, the regular user should not be able to do. And I would say these kind of scenarios can be 100% automated. And I will tell how. If
Okay.
you look one level deeper into it, what is playing out here is not just the API, who is calling the API. So there is definitely the authentication or the user identity in the picture. But apart from the identity, the access control comes into the picture. So to large extent, in the security practitioner's mind, this business logic is boiling down to understanding the identity and access control or the permissions. In some cases, you can call it as, or it might be implemented as RBAC or ABAC or REBAC. And, there's so many ways to implement access control these days. Whatever is the implementation, can I automate this identity as well as the access control completely in my API security testing? The answer is absolutely yes. Again, it starts with, but how do you automate it at scale for all of your APIs? In my opinion, again, it goes back to the discovery. Just like your discovery should be smart enough to understand the authentication mechanisms that you are using, if you make your discovery smart enough to first detect what kind of permissions, or in some cases, if you are not able to do that, you need to have a very clearly defined permissions mapping. You can say
Okay.
these are all the APIs that are accessible. Like, so you can start with
Permissions
very
matrix
basic
of sort.
definition.
Yeah.
Exactly. You define these are all the roles that are present in my system. If it is role-based access control, and these are all the APIs that I have, and these APIs are supposed to be called only by these. I think there are some open source plugins also. There's one that I've seen in Burp Suite extensions. I think it does something like this. So at scale, if you are able to do the discovery and tie it back to feed into this matrix, then you can completely automate it. Or otherwise, you might have to do this matrix definition manually. But the testing part, you feed this matrix and the testing can be automated. So what it is doing is essentially looking at all the APIs that are only supposed to be called by admin users, and it has to take the admin token and then make sure it is able to call it. And then you take the regular user tokens and simulate the calls through that regular user and make sure that the regular user is not able to call any of these APIs. So that's, I mean, I put it in a oversimplified way. There are a lot more nuances, like, when a regular user calls, different API implementations implemented differently. Some written 403, some written 401, some even written 404. The difference between all the status codes, all of that has to be handled, but it can be automated for sure. So that's just to sum it up, business logic in the security practitioner's mind oftentimes is boiling down to validating the IAM, basically identity and access control mechanisms, and you can completely automate it provided you are able to get that matrix. Either feed the matrix manually, or your discovery can feed in that matrix.
Yeah, I think that is one of the use cases. But given that we think of hundreds of use cases, I would say that the way I understand it, and please correct me if I'm wrong, is as long as we can derive a path, that the possible paths that it is supposed to take, we will be able to basically, so any step, whether it is a combination of step or a single step where we are trying to have this matrix, if as long as we can drive it down to all the paths and we have a visibility of that, we definitely can validate those pathways. And it is, if it's taking a wrong pathway, will be very clear to us whenever that happens, and we can automate in that case.
Right. So again, the definition of that matrix is the key here. Essentially, defining that right, because the testing is only going to validate the matrix that you define for all your APIs and permissions.
Right, right. I think so. Yeah, it depends how much time that may take, depending on how complex your application is, at how many places you have this kind of a thing, and then there will also be combinations of what can go wrong, because there are edge cases that mostly security testing is based on top of edge cases in terms of the unexpected reactions that application will give. But one use case is this, that we highly depend on IAM authorization, if that has not been taken care of and things, but then also transactions, different kind of accesses, different kind of data, and if you're supposed to get that or not. So yeah, I think that explains. But while you were talking about the visibility of the permissions matrix, and you were talking about, we were talking about business logic, I was also thinking of another use case in terms of particularly API security automation, where a user, not a user, actually an attacker, is trying to attack an API. And in this scenario, the API is accessed, say, hundreds, thousands of times in a day. So we do have a pattern. So I was curious to know, given that a lot of intelligence is being built in a lot of system today, whether it's needed or not, but that's another podcast, I think. But in terms of having intelligence built in, or having ML, machine learning for these kind of things, where you can actually understand the user behavior, and if it could be an actual attacker behavior when they're accessing an API in an unusual fashion or with unusual set of inputs, is there a role of machine learning in such kind of automation?
Yeah, there is definitely. So let's take a step back. Typically, most of these API attacks, in my opinion, like some of those, every API has its own signature. The spec or schema, different people call it
Yeah, yeah,
differently.
yeah.
So you're defining like these are the inputs that this API takes. And I have even seen security solutions, they don't do anything smart. All they are doing is basically, I am going to validate every API call, stick to this schema. We have defined this schema for a
Okay.
reason. And anything that does not stick to this is a violation, whether it is an actual offensive attack or whether it is some other client-side error. I don't care. So there is no machine learning in those kind of solutions. But I've
Hmm.
also seen the solutions where, okay, let's actually feed in all this API data into, some ML models and some of these, and or some anomaly detection kind of systems, and they are going to detect anomalies. The second one, it is doable, and there are like, especially understanding the bots, understanding fraud. There are some very legit and important use cases you can actually solve. But what I have seen and what I would highly recommend is, don't try to solve the authentication authorization kind of problems using that. You don't need such a complex system. And oftentimes, if there is an authorization bug or authentication bug, it's better you actually test it beforehand and try to fix it rather than trying to rely on an anomaly detection kind of system to find authorization bugs. It's totally unnecessary and maybe inaccurate as well, because if you actually see the authorization based attacks, they don't look anomalous. That you look at, like,
Hmm.
let's say somebody is trying to swap a token. The token is exactly a valid token from your system. It's just
Yeah.
that, or if somebody is trying to enumerate, the IDAR is a very common, most common attack. And this is the problem that I have with some systems where we are trying to use machine learning and all of these things to detect IDAR. It's like, is it really necessary? Question. And also, is it even going to find all times?
Yeah,
This is even
accurately.
more. Yeah. So there are a lot of false negatives, and that is the scariest part because you are counting on it to detect all the issues. So use it sparingly. There are some legit use cases for machine learning, especially like, maybe detecting these bots and identifying fraud and some of those
Hmm.
cases where you cannot do just based on signature or specification or just by looking at. You need to take the traffic from the entire session. You need to take the traffic from the different calls that particular user has made and analyze on a broad spectrum or much bigger space than just one single API call. Whereas any issue and attack that you can actually do at a single API call level, don't try to, overcomplicate it, or don't try
Hmm.
to bring in machine learning and all of those things. And a lot of problems, especially authentication authorization problems, can be tested and verified at the single API call level.
Okay, yeah. So I think that brings about a good point, which I was curious about. Is quite relevant in the API security space, and in the last few years, we have been seeing a lot of it. Earlier, so we have been reporting it like for forever. But in only in the last few years, we have seen a lot of practical attacks happening in this space, particularly when you will have sort of just that you were talking about the denial of service attacks on APIs which are exposed, and it's happening for many organizations. And sometimes it would happen as a wave of attacks on, for example, banking systems only or NBFCs only, or they will take up domains and they will do that in a particular region. That also happens. So it is a big menace. So while you're talking about ML and you're talking about this kind of behavior analysis, does it apply to things like uh, particularly these kind of bot attacks? And can this be used for, so traditionally we've been using rate limiting, throttling and other things, and that's what we recommend. But do you think this then is the right kind of a use case when we want to use, if we need to use MLs in that case?
Yeah, I think let's go. So this is how I see actually. So typically, if it is a plain DDoS, that is like, they are using a pool of IP addresses and trying to bombard you with the same call. And if the intention is actually to take down the service or take down the resources or eat up the resources, those things, I think the WAFs or CDNs, they have all solved this
Quite
problem, in my
equipped.
opinion. Yeah, and oftentimes it's usually based on some of these user agent that comes in the API call, the IP addresses, and so the origin of the call essentially. And that I've seen working pretty effectively. What we are talking about is go one more level deeper. Let's say there's a very sophisticated attack where instead of a human, like take e-commerce, I've seen this very commonly in the e-commerce kind of cases where, uh, there's, let's say there is an item on sale on an e-commerce, and that item is a bit rare. You want to log in and buy it and actually resell it for much higher
Okay.
price.
Yeah,
And
yeah.
that thing, you can automate it, and there is no the DDoS kind of attack here. So you're just trying to react faster than humans so that you get that item first, so that you can go and sell it for much higher price. If you think about it, it seems like HFT kind of case, right? High frequency trading systems, which is
Yeah,
where I
yeah.
started my career originally with. The high frequency trading systems, it's all about that, fast mover advantage. And these cases, but you want the e-commerce system wants to avoid it because that is not the intention. The intention is not for all tech. Actually, IRCTC is a great example.
I
Although
think
in
it used to
IRCTC,
be the best one, but yeah.
exactly.
Please
So,
continue.
so you don't want if you take IRCTC, right? You don't want the tech savvy people to be taking advantage and getting all the tickets. What happens to all
Yeah.
the non-tech savvy people, right? Just because somebody cannot write a program to book a IRCTC ticket, does it mean that they never deserve an IRCTC the train ticket?
They do, they
So
do.
now if IRCTC needs to solve this problem, and that's where it gets interesting because the API call level, a single API call level, it will be very hard to differentiate whether the call is coming from a human or a machine. And in those are the cases where I think you need this advanced machine learning or some bot detection and mitigating from these bots in some of these cases. Otherwise, the plain cases, like this is where don't overcomplicate the system. The simpler system is better, and both for the maintainability, also to really understand and reason about it. So the plain DDoS attacks are solved by the regular systems. I don't think you need machine learning for that in a lot of cases. And so that's how I would put it. So simple authentication, authorization, simple DDoS, rate limiting, all these cases, the problems are already solved, and it's better you test and verify that your system is foolproof for these things. But the clever bot kind of cases where the calls may not be very high, but then they are coming programmatically, and your application, you don't want to support that. It's also very application dependent.
Very application. I think it's a very beautiful and practical example of the use case. So thanks for sharing that. All right, so we'll move on to the infra a little bit. I think a lot of us, many of us have either moved to cloud or are moving to cloud, so that that is a place where we have also, we are doing our development as well for many of the organizations, and that is the place, for us where our APIs will be hosted as well. So I had a couple of things where what I was curious about there. One is Does a specific cloud environment have an impact on API security or enabling API security? And in terms of your entire enterprise API architecture, suppose your entire enterprise infra on cloud that you have, when you look at it, how much of that you think can be concentrated in terms of security controls in two things. One, your API gateway, because we do talk about its capabilities when it comes to API security, and the service mesh that we often use. So we are already talking about automation. So I'm sure we are building all of these controls in the automation that we build in the organization. But then what about the API gateway? What about the service mesh? How much should we delegate? What do you think?
Yeah. Okay. I think this is a loaded question with several sub questions, right? I think the first one, the cloud adoption and having several cloud accounts is actually is the problem, or is the one which is necessitating automating the API discovery, automating the API security testing in the first place. Because prior to this, like if all you have is only one data center or one small environment, especially if it is non-cloud and there is only one firewall through which anybody can enter it, you would think about the API security in a different way
Differently,
completely.
yeah, yeah.
So cloud has huge impact. The more cloud and cloud services or cloud native services that you are adopting, probably the need for API security and API discovery automation might be more. For example, I see a lot of people using AWS Lambdas left and right, and all the APIs exposed through that. And even worse is in some cases they're not even exposed through any API gateway or not even AWS API gateway. Like some of them are kind of exposed directly. It's a very hard problem to go chase
Okay.
all of this. Now you have to again be creative and maybe enumerate all the Lambda functions that you have or all the functions automatically by leveraging AWS APIs and then list them, right? So yes, cloud is at the center of this problem, in my opinion. Also, flipping it, cloud has problems because of APIs as well. APIs or attack surface area, and through which your cloud itself could be compromised. For example, if I have a vulnerable API that is running in my cloud, and they're not gonna stop at just stealing the data that is served through APIs. If they find the right vulnerability, they could actually exploit that to call my cloud, and to maybe they could extract cloud credentials and use that to do some, crypto mining. Probably seems like an old problem. And yeah, I think the hackers are doing something else new, but
Yeah.
but so they could, your entire cloud could be at risk because of a vulnerable API, to put it shortly. So
Yeah.
it's impacting in both the ways. Adoption of cloud and too many cloud accounts and too many usage of too many cloud services is making API security a lot bigger and concerning problem. And vice versa, vulnerable APIs actually pose a lot of threat to your cloud as well. So they are very tightly intertwined, in my opinion. And I think the solutions also, very easily see that these both the platforms will be starting to support or move from one direction to the other in terms of use cases. The cloud native CNAP products could start doing API security or vice versa as well. But coming to your second and third ones, the role of API gateways and your service meshes and how do we leverage them? I think you should absolutely leverage API gateways and service meshes as part of this, because uh, this is one of the reasons I personally say going back to the topic of this presentation, the topic of this podcast, we are saying proactive API security. What you can do proactively, trying to test and all of those things, you have to do all of that. But when it comes to actually deploying them in production, if you are using AWS, if you are using API gateway, any API gateway for that matter, the API gateways are giving so many controls. Like you pointed the rate limiting. Rate limiting problem can be solved at the API gateway level. Some of the API gateways
Yeah.
provide it as native thing. And we spoke about the tokens. You can actually enforce some practices and policies at the gateway level. So you have to
Okay.
combine both of these. The proactive API security testing not necessarily is completely taking care of these things, especially if the gateways that you are using are giving controls and policies that are very easy to enforce. You have to put them in place. Combining both is what is going to take you to the highest maturity level. The service meshes, in my opinion, that's like not every company is using service mesh. So it's all about the adoption curve and maturity curve. But if you have a service mesh, like by all means, you should enforce MTLS so that every API
Yeah.
call is using TLS and it's automatically enforced by leveraging the service mesh. So, I mean, security by definition is like, doing the best and also stacking, one solution on top of other. And I don't think automating the security testing is saying, you don't need to adopt these things. Rather, you should combine all of this.
Yeah, I
What
think
I would actually see, what I've noticed in practice
mhm.
is, this is a great, like, important point to highlight. What I've seen people saying is, I'm using a API gateway. I don't need to test
I
my
don't
API.
need to, huh?
That is
Okay.
completely wrong
Yeah, yeah, I've
because,
heard that.
again, you just because so this is, I have seen cases where I could pass any random JWT token, any random, not linking to your system. I could just go to web, give me generate a random JWT token. I could feed that into the API and I could make a successful API call. What was the gateway doing in that case? Gateway was just the way they configured it. It was just verifying that there is a token, there is a valid token here. I mean, valid as in like they were not even validating the signing algorithm, the encoding, and some of that. They were just making sure the policy was just checking is there a non-null value or non-empty header or not. So
Okay.
just because you have API gateway, don't assume that it is configured correctly. Don't assume that it is taking care of all the problems. So this is a common misconception that I have seen.
Yeah, I mean, we have gone beyond the age of where people used to say, I have a firewall, so I don't need to do test security testing. So now we have moved to these places. And I think the important part that you bring up is while we can push a lot of this, the security controls to the infra side as well, it's important to see how they are configured because many times these products they do come with a lot of things that you can configure, but in your environment either it is non-configurable or you have not taken care of it, and hence a lot of these misses will still happen. Where if you have other controls like of course the security testing automation and code reviews and other things will take care of all of these misses in that case.
It absolutely can. A lot of these products help you, like allow you to do it completely programmatically or with ISC infrastructure as a code. And also for you to do the best configuration, you need to first do the threat modeling of your applications and of the APIs and understand them intimately, and then understand what policies or what parts or what configuration of the API gateway we should use. So I think methodically doing that will go a long way. So you do the threat modeling of your applications, APIs, and all of this, and you decide these are the features or these are the policies that I'm going to use from API gateway. And then let's codify all of that instead of manually opening any dashboard or clicking here and there because that is error prone and it could be reverted at any point with some other action. I think that is definitely the way to go, looping in the infrastructure teams or in general automation, infrastructure automation tools into this.
Yeah, yeah, very well put. That was actually bringing in another joke, but I will maybe just say it. I think there was a time when I used to do threat modeling extensively. And since we're talking about API security testing, and it was across microservices architecture and, taking that. And at the end of the threat modeling, it was an agile threat modeling, and we had like, I think, 45 minutes quick threat modeling that we did, and the question was, okay, now do we still need security testing? So that reminds me of this question has come in so many forms and shapes that it's unforgettable. All
Yeah,
right.
no, that reminds me. I think one thing I've noticed in my like last 5 6 years working specifically in the API security industry, there is a lot of education that needs to be done as well. There's lack of understanding. You might find it funny or silly. I'll tell you one of the reasons API security attack, API breaches or API attacks uh, were not even more common or they are only steadily increasing is because even the hackers themselves don't know some of these or they haven't faced some of these clever attacks, but they are slowly starting to figure it out. Right? I mean, especially some of the hackers, if they haven't implemented some of these APIs themselves, they may not be able to reverse engineer. I mean, I'm not saying everybody. There is a lot of clever hackers. They are able to get ahead and jump on this, but this on an average hacker probably 4 years ago didn't figure out how to crack this API. That's one of the reasons why we are safe. Why we didn't have as many data breaches as I thought would happen. Because like w- when I started solving these problems, it blew my mind to even realize that what are you talking about? Like I've been implementing APIs for 15 years. Why are we talking about API security now?
Yeah.
And a lot of it was like, security by obscurity kind of thing, or maybe the hackers themselves didn't have some of this sophisticated tooling and identification of patterns and all these things. But unfortunately, I would say all these hackers like they are moving very fast and leveraging technologies, leveraging ChatGPT, all these kind and leveraging cloud to do at scale. And now we cannot sit on this anymore. But
Yeah, no,
there is a lot of
definitely.
education requirement
There's a lot of
to get all
education
the
that we
dots.
need. Actually, on that note, like just I think I empathize a little bit from the attacker perspective because they don't have any visibility, having been on the side of testing. There is no visibility, it's a black box to them, first of all. But overall, if you look at the pattern of APIs, it has made it way more structured. The way applications used to be, right? We had to find every interface, every workflow, what will lead to what. You had to be in the system as an attacker and understand it. With API, a lot of things are structured in terms of endpoints and all. It's just about getting that visibility, and like you rightly said, sometimes it will take time depending on the complexity. But once you know, it's definitely much better as an attacker to attack the APIs than the applications.
Yeah.
So I was actually curious about this thing, and one of the reasons that I was quite excited to actually talk to you about the API security space was the role of eBPF. And given that you have done a lot of work in that area, I wanted to understand how can we leverage eBPF when we are automating security for our APIs. Like this is not a straightforward, slightly complex technology even today. Not everybody is skilled in eBPF, but at what stage of automating API security for yourself as a team are you having the right kind of mindset or prerequisites to be able to move on to something like eBPF? What should be your use cases and things?
Yeah, it's a so I'll go back to the earlier point that we discussed, right? We started off saying like how do you solve API security at scale? We start with the discovery. And in my experience, eBPF's role is mainly in the discovery. So
Okay.
like we touched on, there are several environments, several clouds, and APIs are implemented in different languages, different frameworks. And discovering all of these, there are two ways to go. You could actually build a solution that is very, very specific to the API gateway that you are using, very specific to the language that you are using, like Java and Python could have a different solution. Or you could actually go with a solution that is completely agnostic to all these technologies and frameworks and cloud and all this. And that's where eBPF fills in. eBPF is a Linux kernel technology. It stands for Extended Berkeley Packet Filtering. I mean, for those who may not have heard about
Yeah,
it.
thanks for
Uh,
explaining that. Yeah.
yeah, so the beauty of this eBPF for this discovery is it's basically the lowest common denominator. As long as you're running your applications on a Linux server,
Mm-hmm.
it lets you look at the traffic. I mean, eBPF is used for networking, security, observability, several use cases.
Yeah, yeah.
But in the context of API security or API discovery specifically, you can use eBPF to tap into the traffic, HTTP traffic, or even RPC, gRPC kind of traffic. And because it taps in at that lowest common denominator, it is actually giving a single shot solution, irrespective of where you are running your APIs, how you are running, which language they are implemented in all this. And even it allows you to get visibility into even TLS traffic as well, although it's like one more level complex to implement and get it working. But there are like a lot of examples out there in the web as well, in the BF documentation and all of this. So you can easily
Mm-hmm.
go and look at them and get it basically. So that's the role. It's playing a huge role in API discovery at an unprecedented scale, that I would say. So you have like dozens of cloud accounts, multiple clouds you are using. You have your own data center, and your developers have implemented in, 5 different languages and
Hmm.
frameworks. And if is your friend, is like there are other ways. Like again, the lowest common denominator is here is the network traffic, right?
Hmm.
There are other ways to get network traffic as well. eBPF is not the only way. But eBPF, to your point, it's a complex technology, but kernel programming was very complex and even risky, error prone. You could even crash the kernel. What eBPF has done is, like, made an average engineer to actually go and program the kernel. That's how I see it. So it is actually not as complex or as difficult as the previous versions of kernel programming. So it made it super easy. It gives you a safe sandboxed environment where you can actually go and do some of these use cases. So it's actually much easier. It has made it easier, not complex.
But so when you since we are talking about discovery itself, right? I understand that the more diverse your environment is, better it is to use something like eBPF. But apart from it helping with tech stack agnostic discovery, are there, so at scale, are there any other benefits, like particularly in terms of performance or
Right.
anything else that we get with this?
Yes, good that you asked. Tech stack is not the only advantage. Now let's go one more level deeper.
Okay.
I think it's rightly used, and this is where it gets little more complex use cases. The simpler use case, you install an eBPF filter and you get visibility into every API call. That's a
Okay.
lot simpler use case.
Hmm.
Compared to packet capture technology, you can say this is one-to-one. Those are, both are kind of similar. Where you can actually take advantage of eBPF and take it to the next level, which is where we have done a lot of deep work, is you can be very smart. Let's take your application. Let's say it's doing, like, 1,000 calls per minute or even 100,000 calls per minute,
Okay.
and capturing that entire traffic and processing at that scale. It's almost like, you need same compute as your original application, because your original application is
Yes.
processing all these calls and you are also processing all these calls, right?
Yes.
That is not practically possible. And you install this eBPF sensor on every machine, the resource requirement quickly adds up. And the same applies for packet capture, where eBPF is really flexible because you can program it. It's programmable, unlike packet capture, where you're just taking the dump and then you do whatever you want post capturing. You can actually push down some of this programmability into the kernel. So what we do is, uh, what you can technically do, you can say, hey, I'm not interested in so and so ports, so don't give me the traffic for these ports. I'm not interested in these IP addresses, so you don't even get the traffic coming from those IP addresses. So you can be very selective with your inclusion and
Oh,
exclusion list. And now you can have an eBPF sensor that is sitting on a machine. That machine might be getting million calls per minute, but
okay.
by selectively crafting the inclusion and exclusion list, you could only look at only 100 calls out of those million. That's the power it
Okay.
has. But that's when, if you want to do things like this, then it definitely is a bit more involved and not for the faint-hearted.
Yeah, I think that's what I would say. But I think, given that it is possible to do that in a safe way, like you're saying today, many of us can actually think of doing that depending on what scale we want it at, and what is the requirement, and how selective we want to get, how much we want to customize, and how far we want to go with it. So, depending on the
This
use
this
case.
is this is one of my favorite topic, and I'm so excited because we get like a lot of interesting questions, and everybody comes up with this, right? Okay, now you are suggesting to do API discovery leveraging eBPF sensor or agents, and you're asking me to put this on every one of my machine. Like, do you even understand what you're asking me to do?
Ah.
Right? First of all, you're asking me to install an agent on every machine, and
Hmm.
that resource wise, security wise, what security concerns I need to have, and how much resources I need to throw at it, and all this. And that's where, no, I am not suggesting you to put a simple plain eBPF sensor on every machine, and look at every API call, because that's just practically not sustainable and your cloud bill could shoot up. What I'm saying is, if you make the agent sophisticated and smart enough, it is practical without having any impact on your API calls. It's completely passive. It's completely out of band. and the resources can be kept very low. Like even with very high volume servers, we could run eBPF sensor that takes only half a gig RAM and half core CPU. It's
Oh, okay.
so it's
Hmm.
almost like a an art, the like finely crafted art kind of thing. Like,
Yeah.
but if you tune your sensor like that, what it unlocks is almost magical. Because let's go back to that scenario, right, where machines are popping up randomly, applications are popping up randomly.
Hmm.
You don't know which one is exposed to the internet. Mushrooms are coming up. Basically, APIs are coming up like mushrooms. Now, this solution will still make you keep you in charge. You know every API that's coming up out there, and you can look at the data, you can look at the authentication mechanism, you can look at the permissions, all of that at scale automatically.
Yeah, I think if you know what you're doing, it might be one of the best tools in your kitty.
Exactly.
Yeah. Oh, okay. Interesting. So maybe we'll also keep that for, because this is quite an interesting area. Maybe I'll keep it, and itself needs a dedicated, episode. Maybe
Yes.
we'll keep that for a future episode, hopefully, if you do that with us. So I will just have one last question that I have. I think we have talked about this for a lot of application security areas in general, but when it comes to API security, and the overall posture, right, for most of us, whether even in a small to medium to large organization, what security leaders or even leaders in general would want to see is, where your security is, what's your posture. So what are the key metrics that we can measure, particularly at scale or otherwise, when we are determining API security overall for our, enterprise in general?
Yeah, I think key attributes or metrics that I would start with is very basic metrics like how many APIs you have in the first place, and what types of APIs, and how many of them are exposed to the internet publicly, because that definitely is slightly additional risky. How many of them don't have authentication? And what kind of authentication is present on each and every one of these APIs, even if it is authenticated? How many of them are using weaker authentication, like the basic auth and these kind of things? And how many of them are dealing with sensitive data, like whether it is personally identifiable information or any other kind of sensitive data that you care about, that you want to protect your users' data. So and then if you are able to completely automate the security testing, once you automate it, how many of them you actually fully tested automatically, and how many of them are yet to be tested, and how many of them are actually having known vulnerabilities. So these are all the metrics. Like I could come up with like close to 20 different metrics that you as a leader want to track and stay on top of, so that you know exactly what's happening. And even in the cases where you decide to take some risk, it has to be calculated, and you know exactly what vulnerabilities are present. You may not be able to fix it immediately on the day that you find. That's fine, but at least you should know what they are and where they are, which APIs have it.
Yeah, I think so. Apart from the usual vulnerability data that usually people look at, I think you're talking also about a lot of foundational aspects, which, of course, leadership should be interested to see, because that also, in a way, shows the attack surface that you have with respect to API. What's your current state, which is already giving you a lot of information. So the
Yeah.
API population, as I think now onwards I will call it, not just the number of APIs, but the API population and the health overall, and then look how they're placed. So that gives you a clear visibility, and then of course the vulnerabilities and other things with respect to specific APIs. If you have automated that for your entire organization.
Oh, I wanted to add, I missed this. I wanted to add the third party APIs as well. Like, it's not just the Ingress APIs or your own APIs that you're talking about here. You calling somebody else's APIs, the third party APIs, are also very important to care about. You can say, hey, those are not my APIs, but here is a point. You are sharing your data by calling those
Yes.
APIs, and the data that leaves your environment once, good luck with it. God knows whether you will be able to ever protect it or not. So
Yeah,
you
yeah.
really should care about all the APIs that you are calling, the egress APIs and third party APIs, and the whatever discovery solution that you are building, it better actually give visibility into all the third party APIs as well. And you have to have these metrics also covered in the list of metrics that the KPIs that you were asking about.
Yeah, that's an attack surface we don't talk about, but it is there everywhere that you have an API ecosystem, right? They are almost always talking to third-party APIs. So thanks for adding that.
Yeah.
And with that, I think we will end this episode. Thanks a lot, Buchi, for joining us for this episode. How was your
Yeah,
experience?
thanks very much for the opportunity. And I felt like, this is different from some of the others that we have done. Here, we have tried to go in deeper into some of the areas because, you mentioned the audience are like security practitioners and they would like to go into details. But I really enjoyed it. And like I said, some of these are my favorite topics, and, I could talk about them all day, all week.
Yeah.
And
Yeah,
I'm
so
happy to share my knowledge, and people can reach out to me on LinkedIn or on my Twitter as well if they have any specific questions. More than happy to share the expertise that we built in this area if they are implementing some of these things. And in some cases, we even shared some of our modules with people. Like and people reached out saying, "Hey, we are implementing this." Like we even shared some of the modules, the code as well. Like
oh,
I was like,
awesome.
I mean, whatever is shareable, right? Obviously,
Yeah.
we cannot share our proprietary IP, but whatever is shareable, that is useful. In some cases, I mean, in the long term, once we are able to, I would like to open source some parts of it. But like right now, we don't have bandwidth for that. But I'm more than happy to answer questions and help somebody to get these systems implemented in their companies if they are interested about it.
Thanks a lot for extending that offer to our audience, and watch out for his socials. I'll be adding that so you can reach out to Buchi directly in any of the channels, LinkedIn, Twitter, and other places as well. And yeah, I think all of us should take a stab at automating it, and looking around for help in this area, because we have a lot of APIs going forward. There's no looking back. So thanks everyone for joining us for this episode of Breakpoint. We'll see you in the next episode. Bye bye.
Yeah. Thanks, Neelu.
Hey y'all! If you enjoyed this episode, don't forget to like, share, and subscribe to Breakpoint Security Podcast. Your support means that we can bring more such conversations back to you. Share with your friends and colleagues, and stay tuned for more episodes from Breakpoint. Until then, bye bye.